there are always lots of ways to do the problem. There are lots of right ways, there are lots of wrong ways too. If you have a different way of doing it, if it's a kind of quick question, then I'll be able to answer it here. If not, I may have to do it in another session or meet with you individually if you did a problem in a slightly different way. But if you have a question about how I'm doing it, please do ask. Okay, so on this first problem, what we are given is a description of a circuit, and we have that the 1 ohm resistor absorbs 9 watts of power. So when you see power, you know that power equals IV, and that's the only formula I ever remember, although I think that y'all had access to your notes so you could have had the others written down, but I always just derive the others. V equals IR, so I can plug that in for V, and I get P equals I squared R. Or I can solve for I, and I would be V over R, and I can plug that in for I, and I get P equals V squared over R. So the first thing that I'm looking for is I2, and I have this formula right here. I have power, I have the resistance, so I can find I2. So the power is 9 watts, so P equals I squared R. So 9 watts equals I times 1, and so this is I2 squared. So I2 squared equals 9, or I2 equals 3 amps. Okay, so the next thing I'm looking for is I1 right here. I know now that since I know what I2 is, okay, he did current division. All right. All right. So here's how he did it. So we see that I1 and I2 are in parallel, and current division shows us that I1 equals the total current. Well, the total current would be IS equals IS times the other resistance. I'll label these, for right now, I'll label these R1 and R2, so I'll just have the formula here. I1 equals IS times R2 over R1 plus R2, and I2 equals IS times R1 over R1 plus R2. So we have these two equations, and since the two equations are equal, then I can divide these two equations by each other, because essentially what I'm doing is I'm taking this first equation and I'm dividing both sides by the same thing. And when I do that, I see that I get on the left hand side I1 over I2, and on the right hand side IS cancels, R1 plus R2 cancels, and I get R2 over R1. So I know I2, we found that was 3 amps. R2 is 1 ohm. R1 is 3 ohms. So 3, just cross multiplying, 3I1 equals 3, or I1 equals 1 amp. So now I have that I1 equals 1 amp. So now I know, this is not a question, but I know that IS has to equal 4 amps because IS is coming into this node. So 4 amps coming in, and I know I have 1 amp and 3 amps coming out, so I have that. And then we want the voltage source Vs, and since I have Is, I would do it a different way, but he's doing KVL. So KVL, if I go around this loop in this direction, KVL tells me that the sum of all of my voltage changes has to be 0. So as I go into this side, that's I'm going into the minus side, so that's a minus Vs, and then plus, and it's plus because I'm going in the direction of the current. I1 times 3 ohms has to equal 0, or minus Vs plus, and then I1 was 4 times 3 equals 0, minus Vs, wait, I1 wasn't 4, I1 was 1, sorry, I1 is 1. Minus Vs equals minus 3, or Vs equals 3 volts. And then the last part, the power supplied by the current source. So for the power supplied by the current source, I would use P equals IV, and we want the current going in the direction. So when I'm measuring the voltage, so I'm going to be talking about the current coming in this direction, and when I do that, I'm entering into the negative side of the voltage source. But in order to get that power, so I have the voltage right here. If the current is going into the negative side, then I will use a negative 3 volts right here in my equation. And I need to get what I is. I kind of did it informally before, but if I look at this node and I do KCL at that node, current in has to equal current out, so IS has to equal I1 plus I2, or IS has to equal 1 plus 3, or IS has to equal 4. And IS is entering into this side, and so that's 4. So the power is 4 times negative 3, or negative 12 watts. The negative means it's supplying power, so the way you write the answer is the voltage source supplies 12 watts of power. You don't say it supplies negative 12 watts. The negative 12 just tells us that it supplies. Okay, so that is question 1. Are there questions on question 1 before we go on to question 2?
I have a question.
Sure.
So to find the voltage source,
Yes.
why couldn't you just do like a source transformation? So like IS times 3 ohms, and then
Okay, because a source transformation allows you to solve the rest of the circuit, but it transforms the very thing that you're working on, so you can't use it to find the thing that you're transforming. So what a source, what a transformation does. So if I have a voltage source and a resistor, and I have another resistor here, and I have a current source here, and another resistor here, and maybe I'm trying to find the voltage right here. I would do a source transformation here because it simplifies this part of the circuit. but it changes this very voltage source and resistor, and so I can't use it to measure these things. So you have to be really careful not to transform the thing that you're actually trying to measure.
Okay, that makes sense. Thanks.
Yeah, that one, it took me a while to figure that one out. I was in Circuits 1, and I spent like, I don't know how long on a particular problem, because I'd work it one way and I'd get one answer, I'd work it another way, I'd get another answer, and I couldn't figure out why until I figured out what I just said right there, is you can't transform the thing that you're trying to measure and then measure it, because it'll get you the wrong answer. Would it have gotten us the wrong answer here? Yeah, it would have. Right? Or would it not have?
Yeah, it would have gotten 12.
12 for the voltage. Right. And that's not right. Okay. All right. So I am going to stop this